By physical dimensions, we mean the kinds of physical quantities that can be measured, such as length, mass, time, and so on. In physics, there is a very important idea that we should always keep in mind. If you want to write down a physics equation that is at all meaningful, you need to make sure that the left-hand side and the right-hand side have the same physical dimensions.
In physics jargon, we say that the two sides are dimensionally homogeneous.
This is just a special case of a broader rule that says we cannot add, subtract, compare quantities that have different dimensions.
It's a more sophisticated version of the saying, you cannot compare apples with oranges.
So for these reasons, you cannot put an equal sign between quantities that have different dimensions. You can think of this rule as a prerequisite for a physics equation to be meaningful. It doesn't mean that dimensional analysis can tell you if a physics equation correctly describes reality. But be assured, a physics equation that fails a dimension check is certainly wrong. Mathematical functions such as sine, cosine, tangent, exponential, logarithm are all dimensionless. And so are their arguments, which means the things inside the parentheses. Angles are dimensionless. The reason angles are dimensionless is that they are defined as the ratio of two lengths. For example, pi, which means 180 degrees, is the ratio between the circumference of a circle and its diameter. But now you may say, we write degrees after the value of an angle, so that's a unit. True, but you should think of it as a dimensionless unit. Here's an example. Let's check the two equations below using dimensional analysis. The symbols have the following meaning. M is a mass, A, B, C are lengths, and rho is a density. Let's start with the left equation. The left-hand side of this equation is a mass, so we need to check if the right-hand side, 1/6 rho AB squared, is also mass. Using dimensional analysis notation, we can write the left-hand side as uppercase M, a mass, the factor 1/6 as 1 in square brackets, the density as mass divided by the cube of a length, A as a length,
and B squared as the square of a length.
So you get uppercase M equals uppercase M. So this equation passed the dimension check. Now let's look at the right equation. 1/4 rho C squared must be a mass for that equation to be meaningful. So if we do the algebra here, we see that L cubed and L squared do not cancel. Instead we get uppercase M equals uppercase M over L. That doesn't make any sense, like apples and oranges. So we're gonna cross this out as meaningless
because the equation didn't pass the dimensions check.